In this short video, let us derive the transducer power gain GT in terms of S parameters. So this is the formula we have derived for GT already. It is B2 square by Bs square into 1 minus 2L square 1 minus 2S square. To derive in terms of S parameters, we need to find what is B2 value, what is Bs value, and substitute in this formula. So first let us start by finding what is B2. Now referring to the block diagram, B2 is present at the output side. So if you see here, B2 is almost equal to the wave A2 here, and here A2 is equal to this B2 dash here. So I can equate from the diagram, B2 is equal to, it is equal to A2 dash. And similarly from the diagram, A2 is equal to B2 dash. So we can write A2 is equal to B2 dash. And also if you see B2 dash, it is BL. We have a reflection that comes as B2 dash. So B2 dash will be tau L times the reflection number of times the incoming wave B2. So we can write B2 dash is equal to tau L times of B2. So I'm going to write B2 dash is equal to tau L times B2. Fine? Right. So we have written B2 dash is equal to tau L times B2, and here B2 is equal to A2 dash and A2 is equal to B2 dash. So from this what can be equated? B2 dash here is equal to, it is A2. So I can write A2 is equal to tau L into B2, right? Let us have this as equation number 1. Now we are deriving in terms of S parameters. So for a two-port network, we need to write the S parameter equation. So the S parameter equation is B is equal to S into A. So for a two-port network, we write this as B1, B2 is equal to S11, S12, S21, S22 into A1, A2. We are concerned about B2, so let's write the second equation alone. So B2 will be, it is S21 A1 plus S22 A2. Let this be equation number 2. Now let us substitute 1 into, so substituting 1 into, this becomes B2 is equal to S21 A1 plus S22 tau L into B2. Now bring all B2 terms one side. So this becomes B2 into 1 minus S22 tau L is equal to S21 A1. So this implies we can write B2 to be S21 A1 divided by 1 minus S22 tau L. Let this be equation number 3. So now we have found what is B2. Our next aim is to find what is Bs and substitute in this formula. Now to find Bs, from the previous derivation we have already found what is Bs. Bs was equal to B1 dash into 1 minus tau into S. Now let us try to bring similar terms inside. So if you see the diagram, B1 dash is similar to A1. So I can write B1 dash is equal to A1. So from the graph, from the block diagram, we can write B1 dash is equal to A1. So substitute in this place. So Bs becomes, it is A1 into 1 minus tau in into tau S. Let this be equation number 4. So let us substitute equation 3 and equation 4 in the GT formula. So therefore we get GT is equal to, the formula is B2 square. We'll write the formula once again. So it is mod of B2 square by mod of Bs square into 1 minus mod of tau L square into 1 minus mod of tau S square. So we have found B2 in equation 3, Bs in equation 4. Let us substitute the parameters in this equation. So therefore GT becomes Your B2 square is, it is mod of S21 square into A1 square divided by 1 minus S22 into 12 the whole square. It is divided by BA square. So let us take the reciprocal of this. So this will be 1 by A1 square into 1 minus tau S2 in the whole square into these two terms remain as such. So it is 1 minus mod of tau L square into 1 minus mod of tau A square. So here this A1 square can get cancelled. And when we consider RF networks, S11 is almost similar to your input reflection coefficient and S22 is almost similar to your output reflection coefficient. This holds true when feedback is not present. Feedback means when S12 is equal to 0, when S21 is equal to 0, when there is no reflection between the amplifier ranges, when S12 and S21 are 0, we can equate S11 to your input reflection coefficient. This can be equal to tau in and this S22 can be equal to tau out. But this is only true when feedback is absent. So assuming feedback to be 0, let us substitute S11 in place of tau in and S22 in place of tau out. So therefore we will be getting the GT formula is equal to mod of S21 square into 1 minus tau L square into 1 minus tau S square whole divided by 1 minus S22 tau L square into 1 minus S11 tau S square. So this is the formula for GT in terms of S parameters. It is S21 square into 1 minus tau L square into 1 minus tau S square by 1 minus S22 tau L the whole square into 1 minus S11 tau S square. Thus, to conclude the topic, let us see certain formulas that we have used in our derivation. The total power is the incident power minus the reflected power, and the input power becomes the available power under the maximum power transfer condition. So if you see the input side, we can say that when tau in is equal to tau S, when the input impedance is equal to your source impedance. So this is at the RF source side, this is at the input of amplifier. When the two impedances are matched, we can say that the input power at the source becomes available at the input of the amplifier. And certain more formulas, your tau in is A1 dash by B1 dash, tau L we used to be A2 by B2, and by the definition of RF networks, tau in square was the reflected power by incident power. And one more main formula that we encounter in RF networks, it is the S parameters. It is in general represented as B is equal to S into A. So with this we finish the transducer power gain derivation, and this is an important 13 mark for our Anna University examinations. Thank you.